Hey class, how about your weekend? Good? Here's your handout. It's pretty cool. Check it out. Okay. Is anyone have a chance to look at the basketball game of Germany? For any chance? Okay. Okay, never mind. Just random question. It's pretty cool, by the way. Okay, it's somehow also related to our topic today. And I'm Sean, by the way. I told you something about Pythagoras theorem last Friday. Remember? Okay. So today's our object is the application of Pythagoras theorem. Cool. Let's get started. So basically, let's recap a little bit. What is the Pythagoras theorem? I give you the official definition of the Pythagoras theorem on the top of the class sheet, but you don't have to remember it. Yay! Only thing you have to remember is just the shining formula behind, after the definition, which is a squared plus b squared equal to c. What does that mean? Let's draw here is a right triangle. Alright? Remember, everything happened in the right triangle. And we call the two legs of the triangle A and B. And we call the hypotenuse C. So this big formula just telling us that if we added the square of two legs, we can get square of the hypotenuse. That's basically what is the Pythagoras theorem. Okay, let's just leave it right here. And this is what we're going to use today. It's a fantastic big chart. Let's just call it Germany chart. Why? Because Germany is just so cool. Okay, so let's first look at the two examples I give it to you on class sheet. Okay, the first one is telling you that A is equal to 3, B is 4, asking what is C. The second question is telling you A is 3, C is 5, asking what is B. Can anyone tell me what is the difference between the two question? No? Okay, yeah, somebody must know that. Let me tell you. The difference is that the first question is asking us to calculate for the hypotenuse, but the second one is asking us to tell the legs. Okay, so that's the first step of our dealing this kind of problems. Okay, so let's just write it right here on the first rectangle of your Germany chart. Determine what to calculate. Oh, I got no space, okay. Let's write it right here. Yeah, and let's go for the first example first, which is asking us to calculate the hypotenuse. Okay, cool. And so what is the first step to do that? Intuitively, we want to plug in number first and see what can we do with that formula, right? So we just plug in number first. We know A is 3, so 3 squared, and B is 4 plus 4 squared equal to, we don't know what is C, right? Leave it right here, 6 squared. Everybody cool with it? Yeah, definitely. And then we can do some simple calculation with that. We all know that 3 squared is just 3 times 3, 4 squared is 4 times 4 equal to 3 squared. Using your calculator, or you just buy it, and just 9 plus 14 equal to 6 squared, and we got 25 equal to 6 squared. So, what is that? And now, what we want to do with it is C squared, but what we want is just C. So, intuitively, we just take the square root of that, right? So we got square root of 25 equal to C. And everybody knows square root of 25 is just 5. So C equals 5. Bam! You know what? We solve for it. Let's just review a little bit and see how we solve for it. First thing we do is just plug in number, right? And throughout the process of calculation, we got final and the most important step, which is take the square root. Okay, cool. Let's go through the second problem. And basically, it's about legs, okay? It's basically the same like in the first step, which is a plug in number, and we see what's going on. If we plug in number A3, just 3 squared, we want to know b. Leave it right here. And we got 65, so 5 squared. Cool? Okay. And we want to know b, but we want it only on one side of the equation, right? So we do a tiny light transformation for that equation. We subtract 3 squared to both sides of the equation. Okay? Anybody cool with it? Just like the equation, you can do like subtract any number to both sides, right? And then we got 3 squared plus b squared minus 3 squared equal to 5 squared minus 3 squared. Bam, bam. Cancel it out. That's cool, right? So on this side of the equation, we only have b squared equal to 5 squared minus 3 squared. If you like, and then we also go into final side. We just take the square root of that. We got this thing. If you're using calculator, it's pretty simple. It's 4. Okay? So let's review a little bit. After plugging number, what do? We do a like simple transformation. That's the key for this kind of problem. Okay, cool. Let's go through a real life application of that. Let's imagine that Germaline is holding a ball standing a 3-point line. We know that the 3-point line, the distance from 3-point line to the bottom of the basket stand, here's Germaline. Draw a little picture of that. Is 23 feet. Okay, that's not what I'm telling you. That's NBA rule telling you. Okay, and the coach of Germaline told him that the distance from the basket to his feet is 25 feet. So let's draw the basket first. And this distance is 25. Okay, cool with that? And Germaline wants to ask him, what is the distance between the basket and the floor? Here we go. What do you see, huh? You see a right triangle, right? It's happening right here, which is pretty cool. So, let's say this is A. We know A, we don't know A, and B is equal to 23 feet, C is equal to 25 feet. What's that? It's asking about legs. So, let's just go through this process, the right process, right? So, when we plug in numbers, a squared plus 23 squared equal to 25 squared, do the transformation. Minus 3 squared, 23 squared to both sides. And we got a squared equal to 25 squared minus 23 squared. Clear? And take square root right here. Got this. And use like your calculator to do that. It's approximately 10 feet. That's exactly what the distance between the basket and the ground. Right? Cool. So that's basically what we got today, and I have like 3 questions for you. Do it. That's pretty fun exercise.